We just got this scary boy to walk around. Let's put some brains in that head, shall we? Hello everybody and welcome back to creating a horror game from scratch. Last time we got our pawn to start walking around randomly. I did recommend you change up the animations or change their speeds around a little bit as it looked a little clunky. However, I'm not trying to make your game for you. It's more just I'm giving examples, so I hope you were able to get it to work to the best of your ability. Today, let's get the decision-making process a little bit more advanced. As of right now, he is assigned a task in our behavior tree that we created that, if you remember, it receives an execute. It gets a random location with a minimum and a maximum around itself, and it makes sure that it is indeed navigatable. It sets it as a vector on the blackboard, and then it goes to that vector, which is target location, and then waits, and then does the process again. So let's go ahead and make it so he is randomly walking around until he sees us. Once he sees us, he will then go straight for us, like any monster would. Of course, you could do some variants, like maybe he does an animation where he roars, then he chases you. I'm not worried about that. Let's get him set up so he can chase us. Well, in order for him to be able to chase us, he's going to need to use his senses. Who remembers where the senses are? It's the AI controller. So let's head over to the AIC enemy. If yours isn't open, go ahead and open it up. I'll just take a drink of my coffee so you can get that open real quick. All right, is it open? Great. Okay. So what we need to do is we actually need to add something that creates senses on the AIC. So what we need to do is go up here and click on add in the components, and what we're going to type in is, actually I don't even have to type anything in because it's at the top. As you can see, there's one here called AI perception. I'm gonna go ahead and click that. And I'm just going to leave the name AI Perception. And on the right-hand side of the screen, we'll have the details for the AI Perception. Make sure it's clicked on, otherwise it won't be over here. And you'll see that right now, for senses config, we have 0. So what we need to do is we need to hit a plus. And on the index, we will go ahead and do an AI Sight config. So this will make it so he can now see. If we expand it further, we can get to even more details. Like for example, how far away can he see? When does he lose sight? Peripheral vision half angle. So that basically means, because it's set to 90 right now, which if you're not good at math, 90 would be 1/4 of a circle. This is the peripheral vision of a half angle. So therefore 90 would be half. Right now he would see straight out from the sides forward. For testing purposes, though, I recommend you bring this down to 45. This will make it so it's a little bit more like this, like he's got blinders on. So that way it's easier to stay out of his vision if you're testing something, or you'll know to go right in front of him if you want him to see you. That's my recommendation for debugging, but then you'll want to change that value based on the balance of your game. One last thing we're going to do is detection by affiliation. Right now he can detect enemies, not neutrals or friendlies. We're going to go ahead and check all three. There is a setting, asterisk, I think in the project settings, that lets you set up enemies, neutrals, and friendlies. Therefore, you wouldn't want two pawns to see each other and then react the same way as you would if you saw the player. So that's why there's enemies, neutrals, and friendlies, but by default, just turn them all on, let him perceive everything, and it won't matter because I'm going to show you what we're going to do to break down the logic to change what he does depending on what he sees. Cool, so now he can see things, but we need to set up some logic so we can actually use this information. We're going to go ahead and hit compile and save. Remember to do that frequently. In fact, just do Control-Shift-S right now, save all, make that a habit. Let's go ahead and with AI perception selected, you could right click and pull it up, but it's much easier to just look on the right hand side. At the bottom, you'll see we have a list of events here. If yours is closed, just open it on up. You'll see on perception updated, on target perception forgotten. There's all kinds here. What we want is on target perception updated. So the difference between on target perception updated and on perception updated. By the way, this is also a guess based on me working with these. I'm pretty sure I'm correct. I just want to be clear. I'm pretty sure this is correct information, but asterisk again. I'm pretty sure on target basically means, hey, if you want information about a specific target changing in the perception, here it is. But whenever it's just perception updated, anything that happens that changes the perception of the AI is going to trigger it. Does that make sense? So for example, we have the on target. We're going to make sure it's the player and then do some logic. So on target perception updated. What do we want? Well, the actor or the thing that caused us to have an AI update, we need to make sure it's the player. So I'm going to pull out and type in an equal sign to get us this equal here. And then I'm going to right click and do get player character. We're going to plug that into the other asset. So as you can see, it's going to check, is the actor that triggered this the player or character? Go ahead and hit B and click for a branch, or you can type it, whatever you prefer, and plug that straight in. I'm going to grab both these, hit Q, and voila. If whatever updates our perception is the player, we need you to do something. If it's not, don't worry about it. So I'm going to click on this branch. Do this with all branches, by the way. This is something I've started doing. I highly recommend you do it. In fact, I'm working with a startup company, and the number one thing I'm realizing is a huge issue with teams is communication. So you might not have a teammate right now, but you might in the future. Just get into the habit of this. This branch, don't just leave it a branch. Right click it. At the bottom here, there's something called node comment. So what we're going to do is just say, check if player character enter. And then look, there's no more looking at this wondering what's happening. On target perception updated. Check if it's the player character. Boom. We don't even got to look at the nodes anymore. I highly recommend you start doing this. Okay, so let's run the logic through our head because this next step is going to require us to have the full context. Something got updated. It was the player, because we're going to be coming out of true, okay? So something updated, it was the player. So what I'm going to do is I'm actually going to pull out a stimulus, and I'm going to do a break. That'll give us a little extra box here. I'm going to actually even add a pin to make sure this stays nice and organized. Compile and save it. Okay, so on the break, look at all this information we get. We have age, strength, location, all kinds of stuff, okay? What we need to do is we actually need to add a second branch. So B click, pull out a true, plug it into the branch. And we want successfully sensed to be what we're checking next. So we have check if player character, and then we're going to add a node comment to this that says, do we still see them? So the reason we did this is because this runs when something changes, not when something's successful, when something changes. So we need to say, is it the player? If yes, is it because we still see them, or is it because we've lost them? I hope this is making sense. So let's say it is because we see them. We have officially declared that is them, and we successfully see them. Well, let's go ahead and update. Actually, before we do that, I need to make sure it's even. I don't remember the state of the blackboard. Let's go look. Let's go look at the blackboard. So we have self actor and target location, so it wouldn't have worked. We need to add something for the player here. So we're going to add a new key. It's going to be an object, and I'm just going to name this player character. You can be a bit more generic with this, by the way. You can leave it target actor if there is a scenario where it could be multiple different actors that need to fill that slot. For our representation, or our example here, we know it's the player character, so I'm going to be a bit more specific. However, this will not currently work. An object is the highest level a blueprint can be. An object is just a bunch of data that travels around. However, our player is an actor. An actor is essentially one step below an object. It has things about it that are assumed. It means it's in the game world. It's not just random data. It has a presence. It has a way to affect things, okay? So instead of it just being an object, we're going to open up this key type and see how it says base class. We're actually going to open this, and we're just going to go down to actor. If you don't see it, you can type it in. And now we're going to hit save. So now, yes, it's an object, but this object is an actor. Also, if you're one of those people right now, they're like, God, he explains things. So go to one of the YouTubers that doesn't care. They'll throw it all at you, and then you'll be at the end of your project not knowing what's going on. I don't care. All right, so let's go back to our AIC enemy. And so what we're going to do we still see them, right? Remember, we saw it's the player, we still see them. What we're gonna do is we're gonna right click and we're gonna type get blackboard. You want the one, by the way, that is a reference. It's an object reference. So we're gonna click on that. And what we're gonna do is out of this blackboard reference is we are going to pull out and just hit set value as, and you'll see we have bool, class, enum, and all the other ones. We want an object. Remember, this is an object. Yes, it's a child, or it's an actor, but it is an object. So we're going to pull out a true, and we're going to set a value as an object. But what is the value? The value is the actor that's in question. So let's go ahead and add some pins because we don't want this line to be slicing through things. Slight slicing is fine, but as you can see, it just becomes so much easier. Please organize your code. Also, I'm gonna grab all of these and hit Q. There we go. Control-Shift-S, compile. Now when I compiled, you'll see we got an error. That is because we have the object, which is going to be the actor in question, which we know from this Boolean, or this branch is the player. But we don't have a key name. So if you remember in the task, the key was actually a key. It's this blue line, right? It's like we're saying, hey, target location is going to be the key. And then here's the value. Whenever you're not inside of a task, instead what you do is you pull out of key name and just type in make literal, and you'll get a make literal name. So what this is going to do is it's going to try to find a value in the blackboard with this name and then assign this object to it. In this case, you'll remember on the blackboard, we set it as player character. So what we're going to do is we're going to go to here and type in player character. Please remember, it is case sensitive because that's why it says literal, by the way. It's saying this is what we're going to look for. This. So player character, make sure it's got the same exact capitals and stuff. Control-Shift-S, compile. If you're not someone that's confident in typing or remembering things, like let's say you're not on your ADHD meds or something, I wouldn't relate. Go ahead and hit F2 on it, hit Control-C for copy, then you can head back over here and then you can just paste it into the make literal name. I've decided I'm not going to move this here, by the way. I'm trying to make it as clean as possible. This is an art, and I highly recommend everyone try to improve on it as best you can. And there we go. So what did we do? We see them. So since we see them, let's make sure that player character is something that the blackboard has access to. And because we have access to this, now we can add some logic that will make it so we can make a decision based on if we see it or not. So what I'm going to do is I'm going to alt click this arrow. So we're going to disconnect this, okay? And we're going to bring it down and just put it like, oh, I didn't mean to drag anything off. We're going to bring it down, put it like over here. Actually, I lied. I'm going to put it on the left-hand side. I'll explain why in a bit. Then what we're going to do is out of the root, we're going to pull out, and this time instead of a sequence, if you remember, the sequence does left to right, tries to do everything, and if it can't do everything, it will call a failure. So what we're going to do is we're going to pick a selector, and the selector is only going to choose a branch from left to right that meets the correct conditions. So we're going to take this and plug it straight in, the walk around sequence like this. However, we're going to create something new on the right hand side. We're going to right click and we're going to create another sequence. And for this sequence, I am going to click it, and on the right hand side, I am going to name this. We're going to keep sequence, but we're going to name it chase space dash space sequence. So we have a walk around sequence, and now we're going to have a chase sequence. And we're going to drag that over to here. However, how does the selector choose which one of these to go down? As of right now, there's no way. We have no logic set up. So let's give it logic to look at. We're going to learn something called a decorator. So when I click on my walk around sequence and I right click, you'll see that I can add a decorator. There's all kinds of stuff like cooldowns, cone checks. I didn't even realize this had cooldown. I just now saw that. I might use that in my game. Anyway, we are going to be using one called Blackboard. So we're going to go ahead and click on Blackboard, and you'll see Blackboard based condition. So what I like to do is I click on the Blackboard base condition, and on the right hand side for the node name, I don't leave that giant wall of text. I'm going to erase that, and this is going to be does not see player dash BBC. If you get it, laugh. If you don't get it, don't Google it. Anyway, so what we did is we added a Blackboard condition that is Blackboard self actor is set. That's what it's currently set to, but we don't want that. What we want on the right hand side, if you have the Blackboard key selected or the decorator, you'll see we have the key query that is set or not set, and then we have the Blackboard key. So we're going to click on the player character. So Blackboard key, player character, key query. In this case, we want is not set. So when we hit save, what that means is if we haven't given you information about the player character, like we haven't set that, like it's set to none right now, this fails. So don't choose this branch because it's set, so therefore don't run this branch. I don't know how else to say it. However, on the right hand side, if we right click, add decorator, Blackboard, we're going to name this one, go ahead and grab it all, erase. We're going to name this one does see player dash BBC. Control Shift S. We're going to click on the decorator, and in this case, we want player character is set. So, as you can see, this is how the selector is going to make a decision. Blackboard, player character is not set. Oh, that's true. I can run this. Oh, Blackboard sees it does see the player and it is set. Great, I'll run this instead. However, something that you're probably not thinking of is right now, let's say it doesn't see the player. It gets a location. It's told to move to that location and then wait. It will do that even if it sees you. It's not going to stop. As long as it has started this sequence, it's not going to stop. But obviously we don't want that. We don't want him to go finish his patrol or his 5-minute smoke break. No, you see the player, you need to go after him. So if we click on the decorator, you'll see over here there is notify observer and observer aborts. Right now observer aborts is set to none. If we set this to self, for example, what this is going to do is if this changes, right? This Blackboard player character is not set. If that changes, it will abort this entire branch because it's set to self. I'll be honest, I don't remember what lower priority is, and I'm not going to be a YouTuber that lies to you. I forget. It's not that complicated. It has something to do with the position of each route. I believe lower priority would be anything to the right. It's saying, hey, something has changed over here, so everything on the right, please stop. Again, I'm not lying to you. I don't remember. I think that's what it is, though. And then both is abandon everything. Literally abandon everything. Go back to the route, and let's come back down and figure out where we're at. In this case, we just need self. We just need self. This has changed. Abandon this route. Go back to the selector. And now, obviously, because it's set, it'll choose this path instead. And same with this, by the way. We actually want to go ahead and set this to observer aborts self as well, in case we end up clearing this. However, don't worry, we're going to add additional logic later. But for now, that's good. Okay, so let's set up the chase sequence. It's actually quite simple. Well, it's simple until you need to start realizing what the attack range is and things like that. But for now, very simple. And you can leave it simple too if your game just ends with a jump scare when he catches you. It just depends on what you want. However, with the chase sequence, what we're going to do is we're going to pull out, and we're actually going to use the move to. So we're going to hit move to. And with the move to, you can actually set this to anything that is saved in the Blackboard, as long as it's something that's within 3D space. This is where objects stop working, right? Objects are just info, whereas an actor assumes something in the world. So we can go over here to the right hand side and set this Blackboard key to player character. And so bam, let's take a look and see what's going on one last time. Let's go to the AI controller. So something changed. It was the player. Do we still see them? Oh, we do. Okay, well then set this value And with this value set, the blackboard will abandon the random movement and instead go down a tree that makes them chase the player. Very basic setup still, but let's go make sure that it's working. I'll go ahead and plop myself down here, which hopefully he won't immediately see us. And bam, he sees us, and check it out. And we know, by the way, he was randomly roaming because he wasn't in this room to begin with. So the fact he was coming into this room means he was randomly roaming. And now, as you can see, he's charging me down. So let's do one last thing. Let's set it up so he's walking kind of slow until he sees us, and then he starts moving our speed. So essentially walking to running. How do we do that? Well, we need to communicate with the pawn. So the best thing we can do is, let's go ahead and open up our content browser. Let's head over to our interfaces. And right now we have one for interaction, for items, and player. Now we're going to create one for pawns. So let's go ahead and right click. Let's go up to blueprint interface. And we're going to make a BPI underscore pawns. Control Shift S and open it up. Now, all I'm going to do is I'm going to click on function up here at the top right, press F2, and I'm just going to name this run request. And run request will have a input that is a Boolean that just says run with a question mark. And I'm going to hit compile and save. So, because it requires an input, whenever we run this, we basically just need to say, do you need to run or not, by answering the question of the Boolean. So up here, as you can see, we're running up. We're setting this to we see the player character. So this would be a good place to let the pawn know it can start running. So I'm going to right click. I'm going to type in get controlled pawn. And we're going to tell the pawn that we're currently controlling that we want to do a run request. And the run request will be true because it sees the player. So we'll hit compile and save. And then we need to set up if it doesn't see us, but we'll do that in a moment. Let's head back to the BBC enemy, so the pawn. And what we're going to do is in the pawn, because remember, the pawn's the physical being, so therefore that's where we're going to change if it's running or not. We're going to right click, and actually we're not going to right click, I apologize. We're going to go to class settings, and what we're going to do is we're going to implement the new BPI pawns that we created. So that way it has access to the run request. I'm going to save and compile. And bam, we are going to set up some logic whenever we receive a run request. Let's go ahead and hit B and click for a branch. Let's plug in run to the branch. And now it's as simple as grabbing our character movement from our components and typing in set max walk. And now you'll get max walk speed. We're going to copy that and paste it. And we're going to plug in character movement to the one we copy and pasted. So if we're set to run, so true, we're going to set our max walk speed to 600. That is the default speed. And if it is false, we're going to walk around at 200, which I believe is the number we set last time. So that'll be false. And then I will go ahead and right click on the branch, type in, are we running? And then I'll grab all of it, press C, and then just type in run request. So that way we know what this is at a glance. And then I like to show the bubble and zoom. So when you zoom out, you can see easily that it's the run request. And bam, there we go. We've now set up some logic on the pawn. So we're going to hit compile and save. And this time I'm going to try to avoid his gaze at all costs. So that way we can see him walking, and then I'll get in front of him and we'll see him start running. So right now you can see he's moving kind of slow, but watch what happens whenever he inevitably sees us. Oh my God, look. We sent the run request, and now look, he's full on running. He's pissed. All right, let's finish the video by setting it so when he no longer sees us, he continues walking randomly. Now, obviously, we're going to want more logic than that eventually, because, you know, you might want him to investigate the area that he lost you in, stuff like that. But remember, we're starting basic. So what we're going to do is go back to the AIC, the AI controller, and we are going to go out the false branch now, because remember, we check if it's the player and do we still see them. If the reason we ran is because we no longer see him, we're going to do a lot of like what we did up here. So I'm going to grab set value as object, blackboard, and make literal name. I'm going to copy those and paste those down here. I'm going to drag false and plug it in. Oh, I missed it. There we go. And make sure it's roughly even here. And this time we actually don't want to set a value. We want to send none. And the reason we want to send none is because, remember, when the blackboard is setting or choosing what to do, it's going to be looking to see if player character is set. So if this is none, it knows that it is no longer set and can go back to the walking sequence. So we will set that to none. Then we'll grab our controlled pawn. We will send a run request, plug it in, and make sure it's set to false. And I will hit compile and save. And I want to show you what I do with these bigger sets of code really quick. I'm going to grab all this. First off, I need to bring it down. Honestly, I probably should have just moved event begin play up. That would have been easier, but it's fine. I actually like to turn these into several comments and then one overarching. Obviously, I like to use the smaller ones for the branches. But then what I'll do is I'll grab like this top path, for example, and I'll just type in C's player, right? And then I'll go to the bottom, lost player. And then I would like take this whole thing, comment it, and just say perception. And then now you can kind of see how I start to break down the logic and make it very easy to read. This is very important. So anyway, we got that set up. Let's compile and save. So this might be a little difficult. We might have to do this a couple times. But the goal is to use this wall here to lose sight and watch him start walking again. So let's get him on us first. Hey, I'm over here. No, I'm over here. Oh, hey. Hey. Look at me. Look at me with those pearly whites. Sir? I actually don't know why he didn't see us there. Oh, there we go. Okay, now he sees us. Oh, okay. So, the reason he's losing us so easy, you can see the logic's working, but you might be confused as to what's happening that makes him just lose interest so fast. The current reason for that is because his vision, remember we set it to 45, so it's like he's got horse blinders on. So when I do a sidestep, he's lost me. This is one of the reasons we're going to eventually add some additional logic to make him smarter. But that's what's happening. That's why you're seeing him immediately lose interest. Because that's literally how our logic is set, right? Oh, we've lost him? Okay, go back to what we were doing. So, I hope you guys are enjoying this series. Please remember to like, comment, and subscribe. And I'll see you guys in the next video.